These are the first 6 problems from the study guide for Algebra A, Test 2 for Quarter 3. And so let's take a look at the first problem. And actually the first 6 problems are all on factoring, a concept that we worked on this last week and that we're going to continue working on this week. And so looking at the first problem, we see it's a 3-term trinomial, and so, or a 3-term polynomial, which we'd call a trinomial, and we look at the last digit sign. That's really what I'm looking at right there, that plus sign right there. And what that tells me is that the outside terms and inside terms are going to end up adding together, and so when I add those, I'll end up getting a negative 8x. Well, if they add, that means they both have to be the same sign. They both have to be a negative. So what that does is it helps me figure out what goes inside the 2 sets of parentheses in which it will factor 2. So we look at the x squared, and only numbers that multiply to x squared would be x and x. Since they have to be the same sign, the outside terms and inside terms, to add to make negative 8x, but to multiply to make a positive 15, they both have to be minus signs. And so what we do from there is just try the different numbers that multiply to make 15. So you've only got 2 options. You've got 3 times 5, and you got 1 times 15. That's it. But only one of these options will end up adding to make negative 8x when I check these outside terms and I check these inside terms. And so the only ones that end up working would be 3 and 5. And so you can see how it works, because we can go ahead and multiply out the 2 inside terms, and we end up with a negative 3x. And the 2 outside terms, x times negative 5 makes a negative 5x, and those will end up adding to make the negative 8x. And so using this method helps you ensure that you have the right answer, because x times x, the first terms, multiply to make the x squared. The last terms, negative 3 and negative 5, multiply to make the positive 15. And we've already checked the inside terms and the outside terms, and they end up multiplying, then adding to make the middle term, the negative 8x. So there's our answer, x minus 3 and an x minus 5. So taking a look at the next problem, we end up having to, this time, not add, but subtract the outside terms and inside terms. So that minus sign in front of the 35 tells us that the outer and inner terms are now subtracting. Well, one of them will be positive, one of them will be negative. We just don't know which one. And so I'll just put the minus sign in between them for now. And when we go ahead and do that work, we'll end up with a negative 2x. So what that does is it helps us think about what we're supposed to put in for the last 2 numbers that will multiply to make the 35. For we already know that the first terms have to be x and x to multiply to make the x squared. So we're just trying to think of some numbers that multiply to make 35. Well, we have 1 and 35, but we also have 5 and 7. And so we're trying to figure out which of these numbers ends up multiplying to make the 35, which we know they both do, but they need to subtract to make the negative 2x. Well, the only ones that would work would be 5 and 7. So we'll put those numbers in place of the last 2 numbers, the last 2 terms in each of the binomials. So we know that 5 times 7 will make the 35, x times x will make the x squared, so we're checking the outside terms and inside terms to see how we have to arrange the signs to make a negative 2x. Well, in order to make the negative 2x, I need to put the minus sign with the 7, the plus sign with the 5, and that will end up making more negatives than positives to make that negative 2x. So I'll put the plus sign with the 5, the minus sign with the 7, and we'll have our answer. So there it is, x plus 5 and an x minus 7. Well, let's take a look at the next problem here. We have, this time it's a little tougher. We have a number out in front of the x squared term. So we just don't have numbers that multiply to make the last term that either add or subtract to make the middle term. We also have this 2 that gets multiplied by one of the factors of 12. So let's take a look at this one. First of all, I look at that sign. The minus sign tells me, just as number 2 did here, that we're going to end up subtracting the outer terms and inner terms, and they'll make a negative 5x. So I just try numbers that multiply to make 12, but before I do that, I'm going to put in what I know. I know 2x and x are the only numbers that are going to make that 2x squared. So let's go ahead and think of some numbers that multiply to make 12. And so we've got different choices here. We've got 3 and 4, but because we've got this 2 here, we also have to think of doing it the opposite way as well. It could be 4 times 3. We could also try 2 and 6, 6 and 2. We also have 1 and 12, and we have the 12 and 1. But I don't think it's going to be one of those, especially this one here, the 1 times 12. I don't want to multiply 2 by 12. That would get the number to be too big. Remember, these numbers are only 5 apart, so I have a feeling it's going to be one of these first 4. So I'll try that first one here. We'll put the 3 in place of the last term of the first value, and then the 4 in place of the last term for the second binomial. And so all I'm doing, I'm not worrying about the signs right now, all I'm doing is trying to make that 5. So I know 3 and 4 make 12, 2x and x make 2x squared, so I'm just checking the inside terms and the outside terms to see which ones end up subtracting to make 5. And these two do end up subtracting to make 5, and they'll be the only ones that do. And so we want to make a negative 5, so that means I need to put my minus sign with the 8, the plus sign with the 3. So the minus sign goes, well, to make the 8, it's 4 and 2, so I'll put the minus sign there with the 4. 3 needs to be positive to make a positive 3x. And so that ends up working. So we know it already works because we've checked all the parts. Checked the first, the last terms, the inner and the outers end up making that middle term. So the reason I like this method is because it gives us our answer directly in the form that we're going to write down in our answer box or our box solution. And so that gives us our answer a little quicker. Well, looking at the next problem, here, again, I look at that last term, and I look at it because the first one's positive, so I can go right to that last term right now, and I see that it's positive as well. And so that means that we end up having to add the outside and inside terms. And when I do that, I end up with a positive 14x. So right away, I know that when I draw my two sets of parentheses, since the first term is a prime number, 3 is a prime number, the only numbers we could have would be 3x and x. And so we also know, since they add to make a positive, that tells us that we have to have both signs as positive. So I'll put a plus sign here and a plus sign here. Again, they have to both be positive because they multiply to make a positive, and they add to make a positive as well. So we'll go ahead and try some different numbers here. And so we've got numbers that multiply to make 16. I've always got 4 and 4. And I think that might end up working. And as you're doing it, you're thinking, okay, we are multiplying the outside terms here, and we don't want to multiply 3 by something too big. Remember, if it's bigger than 14, it's not going to work because the two numbers, the outer and inner terms, need to add to make 14. So we don't want to multiply 3 by something too big. Like, for instance, if I did 2 times 8, that makes 16. But if I put the 8 here, 8 times 3 ends up making something bigger than 14. So I know that would not end up working. I could put the 2 right here, though, because a 2 times 3 ends up making something smaller than 14. So that could end up working. So I've also got 1 times 16, but I know that's not going to work because 3 times 16 is going to make something bigger than 14. But I could end up trying a 16 times 1. The only problem is 16 already itself is too big, so I know that's not going to work either. So I've only got a few choices that might end up working. I'll try that first one here. Let's see, I'll put the 4 here and the 4 here. But when I take a look at it, you see the inside terms make 4x, the outside terms make 12x. Oh, that does end up adding to make a 16x. Well, that's not what I wanted, though. I wanted a 14, not a 16. So those are the wrong numbers, so we know that one's not right either. But we do end up having to go in and erase what we did here, and then try the next set of values. And so we'll go ahead and erase that part. Erase that a little better, get a better eraser here. Erase it totally. And we'll try the next ones. So we've got the last one that I think it might end up being is trying an 8 here and a 2 here. Let's see if this works. See, 8 times x makes 8x. And then 3 times 2 makes 6. Well, 6 and 8, oh, those do add to make 14, so it does end up working out. So that is the right answer, 3x plus 8, and we also have a x plus 2. Well, let's take a look at the next one here. Here we've got a plus sign as the last term. So that's good. So that's always the first thing I look at. Look at that last term, and I see it's a positive, so that tells me I've got to add my inner terms and outer terms, and they'll end up making a positive 20x. So right away, I know that my factored form is going to have two plus signs. Well, from there, one of the strategies that we talked about last week is that this term, the first term, and the last term, when they're both perfect squares, so you see how 4x squared is a perfect square and it equals 2x. 25, that's a perfect square. So if I put a square root symbol around that, I'd end up with 5. Well, since they're both perfect squares, let's try that. Let's try 2x and 5 and 2x and 5. It might work, it might not. If it doesn't work, then we'd try different values that make 25 and maybe some different values that make 4x squared. But check to see if it works. Sometimes it does, but we do have to also check the inside and outside terms to see if they make this 20x. Well, sure enough, 5 and 2 make 10, and another 2 and 5 make 10, and those add to make 20x. So it does end up working out, and we have our answer. So when we have the same binomials, we could write our answer this way: 2x plus 5 quantity squared. So it's just a factoring strategy to help make the factoring go a little faster. And it's a section in the textbook, I believe it's 8.5, Chapter 8, Section 5, where they look at the first term and the last term, and if they are perfect squares, then check to see if the outside and inside terms are going to end up adding to make that middle term, and they sure enough do. Well, we end up having a binomial, and there's only one set of binomials that will end up making, well, factoring to two binomials, and that's if we have what's called a difference of squares. And difference of squares means that we have two perfect squares and one minus sign. So let's check and see if we do. Well, the first one is a perfect square. It's 10x. 49, that's a perfect square. That makes 7. So what we'll want to do is try those two numbers. Again, the reason why we don't see that middle term is that it ends up canceling out. So let's go ahead and put these numbers in here, 10x and 7, 10x and 7. Put one minus sign, one plus sign, and we see that's how we get the negative 49, because we have opposite signs there. But you've got to check your outside terms and inside terms, see if they end up canceling out, and they should. You see here we have 70x positive, here we have negative 70x, and you see how that will end up canceling out to make 0. That's why you don't see that middle term. So binomials that are differences of squares, they both have to be perfect squares for this to work out. That means they both have to have the same number as the values that go inside the two binomials, but opposite signs, and we'll end up with the factored form. Well, that's what you're going to see for the first 6 problems on the test. We'll take a look at the next 3 problems on the second part.